Hello, welcome back. In this video we'll discuss the symmetry in solids. Solids are classified into single crystals, polycrystalline solids and amorphous solids. Of these three, the single crystals will have the symmetry. A crystal will have a periodic structure and this periodic structure can give rise to the symmetry. The crystal structure can be stated mathematically as lattice plus basis. This gives rise to the crystal structure. Lattice is an array of points in three-dimensional space. This portion is called as the lattice. The small unit is called as the basis. Now we shall define these quantities. A space lattice is an infinite array of points in space in which each point is identically located with respect to the other. Space lattice, or for short known as lattice, it is defined as a space lattice is an infinite array of points in space. The space could be one-dimensional, two-dimensional or three-dimensional space in which each point is identically located with respect to the other. The space lattice is defined as an infinite array of points in space in which each point is identically located with respect to the other. The space lattice can be of one-dimensional space lattice, two-dimensional space lattice or a three-dimensional space lattice. Now we shall look at what is basis. The group of atoms, molecules or ions that is associated with every lattice point is called a basis. The group of atoms, ions or molecules that is associated with every lattice point is called a basis. The basis is defined as the group of atoms, ions or molecules that is associated with every lattice point. The periodic arrangement of the basis in the crystals will lead to some similarities. The similarities is called as symmetry of atomic arrangements or the basis arrangement in the crystal. Crystals can be characterized by the symmetry they possess. Crystal symmetry elements are certain imaginary operations or certain mental operations. A symmetry operation is one that takes the crystal into a configuration identical to the initial configuration after the symmetry operation is performed. Now we shall define a symmetry operation. A symmetry operation is one that takes the crystal into a configuration identical to the initial configuration. And when the crystal, after performing the operation, reaches an identical configuration as before, then the crystal is said to possess a symmetry element corresponding to that particular operation. Then the crystal is said to possess a symmetry element corresponding to that operation. If a crystal has a symmetry operation, means it has a symmetry element corresponding to that particular operation. If after performing this particular operation the crystal goes into a position indistinguishable from the initial position, then we say that the operation is a symmetry operation. The important symmetry elements are center of symmetry. This is also called as center of inversion. The second one is axis of symmetry, and the third one is plane of symmetry. With the help of a cube, we shall try to understand the symmetry operations and the symmetry elements. Center of symmetry. A crystal is said to have a center of symmetry if a point exists within the crystal such that any line drawn through it will have similar situation at both of its ends. Then the crystal is said to be having center of symmetry. A crystal is said to have a center of symmetry if a point exists within the crystal such that any line drawn through it will have similar situation at both of its ends. Now we shall try to understand this with the help of a cube. Now consider this cube. The body diagonals of the cube are intersecting at the body center of the cube. Body diagonals, they will have identical situation on both ends of the diagonals. As a result, this point becomes the center of inversion. Similarly, if you draw a line MN that is passing through the center of the front face and the rear face, it will have the same situation on either ends of the line, which means this line that passes through the body center of the cube will also state that a center of symmetry exists at the body center of the cube. Similarly, the line that is drawn from P to Q passing through the body center of the cube, touching the center of the left face and touching the center of the right face will also have a center of symmetry here, that is the body center. Similarly, a line drawn from top to bottom, that is R to S, passing through the body center will also have a center of symmetry here. When we say similar situation at both the ends, it means that if there is an atom at some distance at one end, there is also an atom at the other end at the same distance. Now we shall look at the axis of symmetry. A crystal is said to possess an axis of symmetry if when the crystal is rotated about the axis, the atomic arrangement looks exactly the same more than once during one complete revolution. A crystal is said to possess an axis of symmetry if when the crystal is rotated about the axis, the atomic arrangement looks exactly the same more than once during one complete revolution. It means about some axis of the crystal, if you rotate the crystal and if you see the same configuration for more than once in one complete revolution, then you say that axis as an axis of symmetry. A crystal can have different symmetry axes. If the atomic arrangement looks exactly the same twice in one full revolution, then you call the axis as a dyad. If the arrangement looks twice the same, then we have a dyad. And if the arrangement looks thrice the same, then we have a triad. And similarly, if the atomic arrangement looks exactly the same for 4 times, then you have a tetrad. And similarly, if the atomic arrangement looks exactly the same for 6 times, then you have a hexad. Here we are having 2 cubes. The line CD passes through the body diagonal of the cube and the line KL passes through the center of the opposite edges of the cube. If you rotate the cube about KL line, then for every 180 degrees of rotation, the cube looks exactly the same or the arrangement looks exactly the same. The axis KL is a dyad or a two-fold axis. Similarly, if you rotate the cube about the axis passing through the body diagonal, that is the CD line, then for every 120 degrees of rotation, we obtain identical configuration for the cube, which means the axis CD is a three-fold axis, is a triad. A cube will have 6 two-fold axes, and three-fold axis we can have 4. Four-fold axis we can have 3. We can have 13 axes of symmetry in a cube. Now we shall look at the plane of symmetry. A crystal is said to have a plane of symmetry when it can be divided by an imaginary plane into 2 parts such that one is the exact mirror image of the other. Plane of symmetry is defined as a crystal is said to have a plane of symmetry when it can be divided by an imaginary plane into 2 parts such that one is the exact mirror image of the other. Now we shall understand the plane symmetry using the cube example. Here we have PQRS plane that is dividing the cube into 2 equal parts. The 2 parts are mirror images of one another. The horizontal plane here can also cut the cube into 2 equal parts. Similarly, we can also have diagonal planes. KLMN, it is a diagonal plane. We can have 1, 2, 3, 4, 5, 6 such diagonal planes. These diagonal planes can also cut the cube into 2 equal parts such that each part is a mirror reflection of the other. We have 3 parallel planes and 6 diagonal planes that can divide the cube into 2 equal parts. So a total of 9 planes of symmetry are possible in a cube. In addition to the operations that we have discussed, one can also have the hybrid operations. A hybrid operation is an operation which is a combination of 2 or more different operations. We have the rotoreflection It is a combination of an n-fold rotation followed by a reflection in a plane perpendicular to the rotation axis. It is a combination of n-fold rotation followed by a reflection in a plane perpendicular to the rotation axis. The second hybrid operation we discuss is roto-inversion. This is a combination of n-fold rotation followed by an inversion. The roto-inversion is a combination of n-fold rotation followed by an inversion. Third hybrid operation we discuss is screw translation. In this, the n-fold rotation axis is coupled with the translation parallel to rotation axis. In this, the n-fold rotation axis is coupled with the translation parallel to rotation axis. Next we discuss the glide reflection. In this, a mirror plane is coupled with a translation parallel to the reflecting plane. In this, a mirror plane is coupled with a translation parallel to the reflecting plane. Here we have come across a variety of symmetry operations, and each type of symmetry is called as symmetry element. A crystal may have more than one symmetry element, and all the symmetry elements possessed by a crystal grouped together are called a symmetry group or a point group. Crystal may have more than one symmetry element. All the symmetry elements possessed by a crystal grouped together are called a symmetry group or a point group. All the possible combinations of symmetry elements lead to 230 space groups, can be divided into 32 symmetry classes and 7 crystal systems. In this video, we have started by understanding the crystal structure. We have said that lattice plus basis is equal to crystal structure. We have seen what is lattice. We have seen what is a basis. We have seen what is a symmetry operation. We have seen the three important symmetry elements: center of symmetry, axis of symmetry, plane of symmetry. We have seen center of symmetry with an example. We have seen the axis of symmetry. We have said one can also have dyad, triad, tetrad and hexad axis of symmetry. We have seen the number of axes of symmetry a cube can possess. We have said 13 axes of symmetry are possible in a cube. We have seen a plane symmetry. We have said 9 such planes of symmetry are possible in a cube. We have seen the hybrid operations such as roto-reflection, roto-inversion, screw translation, glide reflection. We have seen what is a point group or a symmetry group. A combination of symmetry elements can lead to 230 space groups that can be divided into 32 symmetry classes and 7 crystal systems. Thank you.